Once you know what an array is and what it isn't, then you're ready for the idea of C-style strings. A C-style string is an array of characters, but remember that an array does not carry around in itself how long it is. The decision was made that if you put a special character to indicate the end of the string, then you only need the pointer to the beginning of the array to completely describe the string. You can basically go through it a character at a time, checking for the special character. When you hit the special character, that's the end of the string, and you don't need to know a separate variable, either how much memory has been allocated or how much memory has been used out of your array of individual characters. So this special terminating character is called the null character, and it actually is the numerical value 0 in memory. If you want a null character, you get one with single quote, \0, single quote. The backslash is an escape sequence. This isn't the same as a null pointer, even though they both have the numerical value 0, they have different types. It's not the same as single character 0 single character, which is an ASCII representation of what you get when you push 0 on your keyboard. And it's not the same as double quote 0 double quote, because double quote sets up a literal string, and a literal string ends with a null character. So in fact, double quote 0 double quote is the single character 0 followed by a null character. It's a 2-character long string. Or at least it's a 2-character long array of characters that represent that string. In fact, one of the things that really trips people up when they're working with C-style strings is that you need to have room for that null character. So if you want to store hello in a C-style string, you need 6 characters, one for each of the 5 letters in hello, and one for the null character to say that you're done. There's this function called strlen that will tell you how long a string is. It goes through comparing each character to the null, and while it's counting, it will return 5. You need to add one for the null yourself when you're going to manipulate that string or make your own copy of that string. Strlen is one of a whole pile of functions that start str. You'll find them in the C string header. I find most people are a little bit thrown off by them. The copies to some people appear to be backwards in terms of source and destination. More importantly, a lot of these functions are unsafe. If you hand them strings that are not null terminated, they'll walk through memory forever looking for the null termination, and possibly right into where code is supposed to be kept. This is the heart of, say, a buffer overrun attack. In your life, you want to use standard string from the standard namespace, or W-string if you need wide strings. And you can convert back and forth between these C-style strings and a standard string, or from a standard string to a C-style string, and all equivalently as well for wides. But you will have to read other people's string code, and I also want to show you some of the danger, because they are arrays under the covers, that come with those old style strings. Here I'm setting up a string called S1, and I'm initializing it by passing in a quoted string. The type of S1 is that it is a char star, a pointer to a character. Just as when we dealt with arrays of integers, we could call that an int star, a pointer to integer. So hello is actually an array of characters with a null on the end, but S1 is pointing to the beginning of that. And if I step over this line, you see that the debugger knows what S1 is. I can hover over it here. It all makes sense. If I ask how long that string is by calling strlen, I get back the answer 5, which is just for the 5 letters in hello. So let's say that I would like to make another string that contains S1 and this literal string Kate. So I take the length of S1 and the length of Kate, add them up, and make myself a new array of characters that's that long. That's how it's done. Then I'm going to use this strcopy function, and strcopy copies from here into here. It says bad pointer because we haven't gone over the new yet. Let's step over the new. Okay, now it's a good pointer, and step over with the strcopy. And if I now look at S2, it says hello, because I copied S1 into it. Then we have this strcat, which concatenates another string onto the end. We've set up enough room for it. And I hover over here, it says hello Kate. Everything looks peachy, but it's not. It's not peachy because when I set up S2, I did not allow room for the null. And yet the stircat has put a null. What stircat actually does is it goes through S2 here looking for the null, and when it finds it, it takes away and starts copying the new characters there, and then when it's done, it puts another null at the end. Just as in the arrays example, I've stomped on a piece of memory. In this case, it's out on the free store because S2 is on the free store. And I've written past the end of my string and been a bad person. But I've had no help at runtime. Nothing has warned me that I've been bad. So just keep in mind that that's happened and that we are going to get bit by it eventually, and we'll carry on through some other ways to work with strings. Here I'm making an array of characters called hello, and I'm using the same initialization syntax that we used for integers to put space world into my array of characters. Let's step over it and take a look at it in the debugger. So what's all this junk? And whenever you see in the debugger an awful lot of identical unreadable symbols, those are typically values that are put into unused memory by the debugger to help you spot exactly the bad thing that's happening here. I did not put a null character at the end of my array. And therefore, nobody in the strlen, strcpy, strcat world has any idea where this string actually ends. They'll keep traversing through memory till they happen to bump into a 0 that just happens to be in there. So if I ask how long it is, J is 19, because that's how far it had to go to find a 0. And it could have been worse. It could have had to go thousands of characters to find a 0. If you want to initialize an array of characters and not have to manually remember the null character, using double quotes takes care of it for you. So this one here, which is using better, if I hover now, he's exactly the right length. And if I hover on the string, strlen returns 6. This is all good. So try to initialize strings using double quotes rather than a specific array of single quotes. If for some reason you have to do a specific array of single quotes, then put the null character on the end. Really, you want to work with standard strings, and it's pretty straightforward to go back and forth between them. Here I'm going to build a standard string from S1. So S1 has hello in it. And now S has hello in it. And I can look at properties like the size and the individual characters super easily. And S knows its own size. And S can handle things like, hey, tack some more characters on for me, will ya? And when I do, it resizes itself. It does all the right things. So now it says hello modern C++. And if I expand this, let's scroll down so it's got more room. It shows the size is now 16. It actually bumped the capacity. It was 15, now it's bumped it up to 31 to try to make that room for the extra characters. It's just a lot easier to work with the strings from the standard library than with the car stars. Now what about the other direction? Someone gives you a string from the standard library and you need to turn it into a car star for somebody? Well, 2 steps to it. 1, allocate some room, and you'll notice I've remembered the +1 in this one. And then 2, copy from the standard string to the old style string. Now I've commented out here a couple of things that you might have liked to have done. You might have liked to have said S3 equals S and had the equals operator magically convert. It doesn't work. There is an element within every standard string called C_stir that you can call that member function and get back access to the raw pointer, the raw string inside of it. But again, you can't just use equals on that. You have to actually use strcpy to copy the elements out. So if I step over this line and then take a look at S3, you can see that it does contain hello modern C++. The debugger is only willing to show me the first letter of it. It doesn't have those rich properties that the standard string had. Now just as with the arrays, anytime I new anything up on the free store, I need to clean it up with delete square bracket. And when I go to delete S2, remember S2 all the way up here? That's the guy who I didn't allocate enough memory. I forgot the +1, so I've got the length of hello and the length of +Kate, but I don't have the +1 for the null terminator. And then we cheerfully wrote past the end of S2. Didn't get any warnings then, but when I go to delete it, bam, heap corruption detected. Now, it's not giving me as much information as when I had the stack corruption. So you really have to find out what line you're doing it on. I was deleting S2, something's wrong with S2. So if I abort this, put the +1 in here, and run again, run down to here, step over this line, no more heap corruption. Because strings are C-style arrays, they carry the same pain as C-style arrays, which is you can accidentally write past the end of them without any warning, without any automatic growing. Running debug builds will help you a little bit to find where the problem is, but the real solution to this problem is to use standard strings and try to use arrays of cars that have to remember to have null characters on the end of them as little as you possibly can.